Yo, what is up? My name is Daniel Stepp, and this is my Lab 3 Black Holes and Orbits Physics 1 lab report. Okay, let's dive in. Little introduction. Hey, my name's Daniel. In this lab, we talked a lot about gravity, about the universal law of gravity, and about orbits and how planets move around different other planets, and how ships are moving around different other planets, and how each planet has a force on everything else because of gravity. So what's the purpose? Why do we do this? The purpose of this is to demonstrate the orbital motion simulation, which I'll show more later, and to talk a little bit about Newton's second law and the universal law of gravitation, which pretty much says that um, force equals mass times acceleration, and that every object has a force of gravity on every other object. And so what physics principles were used? We used F equals ma, which we'll talk about a little later. We also used this law of gravity, this F equals g m1 m2 over r2. G is the universal gravity constant, which is 6.67 times 10 to the negative 11th. And m1 and m2 are the masses of the two objects in the system. And r squared, r is going to be the radius between the two objects, the distance between the two objects. And all this is multiplied by negative r hat, and was famously discovered by the guy on the left. I mean, the guy on the right. Okay, so what did we learn? Well, we learned about physics simulation. We learned about the force of gravity and manipulating formulas. If you look back at that formula I showed on the last slide, we can mess that around. We can change different things depending on what we know, and can find other cool, nifty little bits of information by being able to figure out the mass of one object if we know everything else, or knowing the radius if we know everything else. So we were able to play around with that and learn a lot about the force of gravity through a physics simulation. So, and this lab had two parts. Part one, the system was the star, and the surrounding was the black hole. And part two, the system was the ship, and the surrounding was the moon and the planet. So the initial conditions in part two for the spaceship, here are the speeds that I figured out. And I'll be showing everything else later. But this is my initial speed that I found. And then here's the experiment. So for part one, we just had this star around an orbit, or around a black hole, and then we were able to find the mass of the black hole down here at the bottom by manipulating some of those formulas to show us some cool little things. And then we also found in part two, we were able to do this cool thing. So part two, if it'll load. There we go. Come on. Sorry for the delay. Here we go. So you can see the purple, or the pink ship is going around the cyan moon, and it's all going around the blue planet. And so it goes around for a while. It's pretty cool that we were able to get that to work. Here's my code. Here's my initial constants as well, showing the gravity constant, the mass of the moon, planet, and ship. And here are my initial speeds and stuff. And then here is how I figured out the force. So the force, F net on the moon would have been the F net of the ship on the planet, and the F net of the planet, both on the moon. And then the F net of the ship would have been the F net of the moon on the ship plus F net of the planet on ship. And then we were able to apply Newton's second law, which is force equals mass times acceleration, and use these position update and velocity update formulas to make everything move. So once again, this is what it looks like. If it goes for long enough, the ship stops perfectly orbiting the moon, but worked for a while, so I was pretty proud of it. So if we go back to my slides, could have made a couple errors here. First of all, the mass I found in the part one wasn't exactly perfect with the average black hole, but that could have been error. That also could have been just the seed that I got. Tough to tell. The bird right in front of me. Hopefully it doesn't attack me. Okay. Other errors I could have made, the speed. The initial speed could have been a little more fine-tuned, potentially, to make it, orbit around for a little longer, but only so much I could do in the time I had. So the discussion questions discuss how F net force and its parallel and perpendicular components are different from the rate of change of momentum in its parallel and perpendicular components. So although mathematically these things are very similar, FNet is a little different than the perpendicular components of the momentum. Momentum is mass divided by velocity, or mass times velocity. And so that's going to care more about the perpendicular forces that are acting on it. And then if this imaginary system had a black hole, a star, and a planet and a moon, we'd want to make sure that we consider each force on every force. The black hole has a force on the star, the planet, and the moon, and that's the same for all of them. So thanks for